So today we looked at the volume of some shapes. So in actuality, we didn't look at every single shape. We looked at prisms. Just volume of prisms. So prisms, what makes them different from our other three-dimensional shape is that they have two identical and parallel bases on opposite sides of the shape. So identical, they have to be the exact same size in every possible way, the same angles, the same side length, same everything. And then parallel, that if one's running straight up and down, the one on the other side is straight up and down. If it's perfectly flat on the bottom, it's flat on the top. It could be rotated in any one of those ways, but one of them mirrors itself on the opposite side of our shape. So some of the more common ones, rectangular prism. This one gets its name because its base is a rectangle. I know, shocker. Rectangular prism, you have this rectangle that's on the bottom of the shape, and it has an exact replica of itself completely on the other side up here at the top. Rectangular prisms are hard to start with because they're actually a perfect representation that every side is its own base. So the top and the bottom are perfectly mirrored, but also looking at this rectangular prism, this front side right here, this right side, is exactly parallel and identical with this side over here. And front and back are also perfect. So rectangular prisms, this one's not the easiest one to, like that. So because they're so special, their formula is actually one of the easier ones. The formula for a rectangular prism is length times width times height, capital H. Very different than little h going forward. So if I take the length and the width, so I find the area of this rectangle right here, I'm then going to multiply by the distance from one base to the other base. Length times width times height. For triangular prisms, they get their name because their base is a triangle. So even though this triangular prism over here on the left is sitting on that rectangle, if we were to look straight across, we don't have an identical rectangle sitting up here. We don't have that. Then we're like, well, Ms. Carla, if we look at this right side right here of this tent, this rectangle, it looks like it has a identical buddy on the other side. And that does appear to be about the same rectangle. But they're not parallel. They're not mirrored directly across. But the other shape, this triangle, has an exact replica of itself on the other side of our problem. So to find the volume of a triangular prism, we're going to find the area of that triangle, base times height divided by 2, and we're going to multiply by how tall this triangular prism is. So in this problem, I have my base, I have my height, just like a regular triangle, but then we're going to multiply the distance between the two triangles. Big height. So if we had this picture over here, let's say that's our base, that's our little height. The big height is the distance between the two triangles, right there. Then our third and final prism is the trapezoidal prism. It gets its name because its base is a trapezoid. We have this trapezoid right here in the front. And then we have its identical buddy in the back. Also, you have the one on the bottom, directly mirrored with the one on the top up here. Just kind of try to save some time by moving that instead of just redrawing. So if we were to find the volume of a trapezoidal prism, we're first going to find the area of the trapezoid. So we're going to have base 1, base 2, or vice versa. In my last video, I did this top one as base 1, so I'm going to stay consistent. Base 1, base 2. So here's base 1, base 2, times the height, little height, and then we multiply by how far away are the two bases. How far away is the top and the bottom of our trapezoid? So let's practice on a few of our problems. I have a couple visual aids to help us out here. Rectangular prism. We're going to take length times width times height. So we're going to take 4 times 3 times 2. And the volume gives us 12 times 2, 24 units. And then because we're dealing with volume in three-dimensional space, this is units cubed. Units cubed comes from this next description right here. So I'm going to first start by finding 4 times 3. That gives me 12. So if you look right here, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 cubes. That's the area of this first layer. But then the height asks us to go up 2 sets of these cubes. So 12 plus 12 gives us 24 total cubes of volume. So that's 24 cubes in our respective units. 24 units cubed. So for this one, if we want to just use our picture, 2 times 2, so this thing's got an area of 4. So if I kind of cut this like this, 2 squares by 2 squares, it's got area of 4, and then I'm going to stack 4 sets of cubes on top of each other. 4, 8, 12, 16 total cubes. We see that's how we find the volume of 2 times 2 times 4, because that's length times width times height. Units cubed of volume. For a triangular prism, there we go. We're going to find the volume by taking base times height divided by 2 times the height of the entire prism. So we're going to start by looking at just the triangle. So here's just the triangle. I don't care about the rest of the picture, just the triangle. I see my right angle symbol right here, so that means base and height. Then the 12 over here is how far the first triangle down here is away from the second triangle up here. I end up getting 12 divided by 2. So I get 6 times 12. And our volume is 72 units cubed of volume. And then last, we'll practice a trapezoidal prism. We find the volume is base 1 plus base 2 times the height divided by 2. And we're going to multiply by how tall this prism is. So base 1's right here, base 2, or vice versa, and 2 is that height. 5 plus 3 times 2 divided by 2, and then times 11, the height of the prism from one trapezoid to the other trapezoid. It's kind of separating the two ends. So we end up getting 8 times 2 divided by 2 times 11. So that's really 8 times 11. So our answer is 88 units cubed of volume.